This is session 3AD. Please remember to fill in your feedback forms at the end. This is Dan. I'm sure I'm going to say it wrong. Vegan. to introduce to do this session from IBM. And the session title is Proactively Reduce System Issues by Leveraging Machine Learning and Real-Time Anomaly Detection. If you have any questions during the session, please pop them in the chat. Either I'll interrupt Dan for the question, or Dan will see it himself and answer it. The other thing that I'd like to mention is this year's charities. The charities are the blind dogs, guide dogs for the blind, a very worthwhile charity, and the RNLI, the Royal Lifeboat Institute. So if you would be so kind as to show your appreciation for the session by donating. For each £1 you donate, you will receive a raffle ticket. To get your raffle ticket, you need to enter your receipt number, which you can get. I think there are some instructions. So without further ado, over to you, Dan.
Okay, thanks, Anna. So welcome and thanks for joining. I hope everyone is doing well. So as Anna mentioned, my name is Dan Wiggins. I'm a senior product manager here at IBM, and I'm going to talk today about some of our solutions around how we leverage machine learning for real-time anomaly detection. So I'm going to start today's session off with a little kind of imaginary exercise that is kind of all too often across our industry, especially as we've been going through the digital transformation for a number of years now, and the fact that IBM Z is very well integrated into our hybrid clouds. And this is kind of something that back in my development days here at IBM, I've kind of experienced myself, especially helping to manage an on-cloud offering that we had here at IBM. So just kind of picture that you're managing the operations for the IT infrastructure of your leading customer-facing hybrid application with IBM Z. And as part of that, as many of us are doing, we're embracing continuous delivery, and your team makes application changes every other Friday. So we're always continually rolling out new and exciting changes and features and enhancements that our end users find delightful. And just up before we have our change window, we wanted to get one last thing in that won't break anything as part of the rollout. And how many times have we heard this before? It's just a minor change that we can go in and make this as part of our change. So the question becomes is, will you end up in a war room on Monday morning? So when everyone starts to come back and workloads start to ramp up again, is that small change going to bring you into a situation where you may not want to find yourself to start off your traditional work week? Or will you be able to be alerted of anomalous behavior, allowing to take corrective action before your customers are impacted? So kind of in my experience with helping to run the operations and DevOps for that on-cloud solution, our goal was to always try to catch any problems that might be going on with those services before our clients were able to find out. So that's really the goal of what we're trying to do with this, and I'll kind of put this in context of a little bit of what we might have seen earlier in the conference event this week. So if you were able to go and listen to my friend and colleague Domenico Del Terrio earlier in the week, he talked about our overall journey to AI ops. And with the presentation today, I'm going to drill down into one specific slice of that. So if you're not familiar, IBM has an approach to helping our clients accelerate the journey to AI ops. And with this, every one of the clients that I've talked to is starting their journey in a different place. Maturity levels are different in various facets and areas of this, and we've really tried to break this down into 3 distinct areas with differences of capabilities in those areas. The first one is detect. This is where we look at monitoring our hybrid infrastructure and applications in order to detect issues and operational anomalies. The next is decide, where we can analyze those issues and anomalies to help isolate problems and identify root cause of operational issues. And then lastly, we want to be able to act to reduce impact to your customers with improved resiliency. And what we're trying to do as part of this AI ops journey is deliver AI, artificial intelligence, into every single facet of this journey. So if we take a look at some of our challenges and the overall life cycle of the incident management workflow, and again, I'm going to kind of highlight where we're going to focus this presentation on is that left side of this is, kind of going through that full incident workflow. We have the mean time to detect, and what we're really trying to focus on with leveraging machine learning and anomaly detection is to bring that down to as close to real time as possible. If not, try to be a little more proactive or predictive when we might start to see operational issues. And to do this, we're leveraging machine learning and trying to really understand our clients' environments to help achieve those results. The next phases are really kind of when we start getting into those decide areas where we have the mean time to identify and the mean time to know, where we can isolate and diagnose problems, and then getting down to the kind of act side of the wheel, where we have the mean time to repair and then the mean time to resolve and deliver those lasting fixes. So what we're going to focus the presentation on today is really the left side of this workflow, where we have the mean time to detect. So if we drill into the detect phase, there's really 3 key capabilities that we have. We have our monitoring and observability, our application performance management, and as you might have guessed, today's is really focused on anomaly detection. And really all 3 of these have evolved and worked together. So if you think of kind of the evolution of how we've looked at our environments, full stack monitoring has been around for decades. It's not going anywhere. It's not going away. It's still very heavily needed today, and this is kind of where we started out in terms of trying to understand when we might be experiencing problems. And if you kind of think of the history of this, a lot of this was originally based on setting static thresholds that, if we increase to a certain level, we wanted to generate an event or an alert and say, hey, we got up to this, let's start to sound the alarm. And, we started to adapt that and bring in some dynamic thresholds and looking at how we monitor environments in that aspect. Then kind of in the last little over a decade or so, the birth of APM solutions really started to take hold. And this was looking at end-to-end transaction tracking across entire applications. And these were very good at kind of finding slowdowns and bottlenecks as we're going through that application topology. And these solutions are very good at looking at the entire application stack, where you have the traceability that's ingested into those. So we have a number of sessions over the GSE conference that we talk about observability and how that plays in, and application performance management is one of the key pillars of that. And lastly, today's session is really focused on anomaly detection, and what we like to call this as intelligent anomaly detection in order to avoid costly incidents. So in the past, I've talked about the cost of an outage and, in terms of the effects of downtime and lost revenue and lost productivity and potential government and regulatory fines and client and customer satisfaction issues where they may not want to come back and use the service again and may go to a competitor. All of those kind of wrap up into the total cost when we experience application issues. So in August of this past year and in September, we announced a new solution for IBM Z, IBM Z Anomaly Analytics with Watson. And it's really focused on 4 key capabilities within this solution. And for those of you that know a little bit of the history of some of our AIOps solutions, this is a follow-on solution that came out of what had historically been our Z operations analytics. But this is purely focused on machine learning and anomaly detection for helping drive our client's journey down that path towards AIOps. So if we look at the key capabilities that I'll kind of talk to as we go through the rest of the presentation today, the first is environment modeling. So this is, the key tenet to leveraging machine learning is we want to understand and visualize normal behavior for your environment, subsystems, and messages. So we're looking at leveraging historical data to build a model that's representative of what is normal. The next 2 are actually when we go and detect operational anomalies, and we're doing this across both metrics and messages. For metric-based anomaly detection, we're looking at key IBM Z subsystems, currently DB2, KICS, and MQ, with more that we have planned to come. The next is message anomaly detection, where we're looking at system messages that are always being generated. So we can look at these in an unattended fashion. And we're looking for differences in occurrence of messages, frequency, or sequence of system messages. And we'll talk a little bit about what this looks like as we get into the presentation. And then the last part of this is once we find an operational anomaly, how do we go and identify or notify operations of this? And we can do this through generating events. And we can look at one special use case of how these events can be integrated within your systems. And this is looking at the case where we can integrate this with IBM Cloud Pak for Watson AIOps. So let's start with the event modeling parts of this. And there's a couple of key things that I'll want to mention as I'm going through and talking about this. And those are kind of listed on the right side. But this phase is all about what's learning about your environment and understanding what's normal from history. And to do this, we leverage historical data, use our machine learning engines. In one case, it's Watson Machine Learning for ZOS. In another case, we have an embedded Melody engine for messages to take that historical data and understand how your environment works on a Monday morning at maybe when markets open versus a Sunday morning at 3 a.m. Those are very likely to be very different periods of workload. So we want to take data that is recent and relevant to build these models. We also want to take data that has been normalized. So we want to take out any periods that you may have had issues or workload anomalies, because we really want to get as accurate of a model of what we would expect it as normal as possible. So the data that we train on is very important to do this. So we can build that model of what is normal. Now, the way that we've taken an approach to this, especially on the metric side of this, is to look at days of the week versus weekends. And this all plays into what's known as data seasonality. And you can think of this as getting very fine-grained, or how fine-grained you want to get with your models. So the approach we've taken takes roughly a month or 2 months worth of data to go and train to build an accurate model. And that's just looking at days of the week versus weekend. If we wanted to start to take into account other periods of time where maybe we had every other week we had payroll or end of the month invoicing and billing or doing quarterly reports, that requires a bit more data to start to do those. So now we're looking out at maybe 6 months, 9 months of data to start to build those accurate models. Kind of the holy grail, or really where we really want to get to, is we would love to have a model that could say, this is what our environment would look like on every day of the year. So we would take into account different holidays, or here in the U.S. Where I'm based, we have our Thanksgiving holiday, and our large shopping day is the day after, which is will be our last Friday in November, which is our Black Friday, and then we follow that with Cyber Monday, which are large shopping days for the holidays. And to start to build out models to account what we would normally see on those kind of days, if you think we need maybe 10 or 12 different data points for those, we would need 10 or 12 years worth of data. And I don't know any one of our clients that has had the same hardware, same workload, same environments, and have all of that data to be able to accurately build a model such as that. So, we have some constraints to work in, which is why we've kind of landed on looking at the days of the week versus weekend, because that's something that we have a pretty good accurate model to look at, and can handle most of the small minor fluctuations that we have without raising a red flag that something is broken or going on. So once we have the model of what's normal, we start looking at live data and how that compares to the model. And what we're looking for are trends and patterns of when live operational data starts to deviate outside of what is normal for that period of time. So in terms of metrics, this could be where KPI values are going too high or too low. For messages, we might start seeing messages that have a very rapid frequency. So if we start seeing user authentication issues, we might have an issue with our authentication service, or we might have someone that's trying to gain access to a system. So we're looking for all of these differences and trends and patterns where we wouldn't normally have seen those. Now, an anomaly doesn't always mean that there's a problem. An anomaly just means that something is different. So it could be something that is easily explained away. Maybe we had to start up a job or a batch job, and we had some things that were running that threw off some of our transaction numbers or CPU utilization counts. Those are easily explained away. We knew something was going on and happening in that space. But maybe with that change that we made on that Friday evening, we're starting to see our active DBATs or database connections start to creep up on Saturday morning, where they normally wouldn't be for that time of day. And if we had static thresholds, we surely wouldn't hit those, because we're well below what we would normally see as kind of that high water mark. But as we start creeping up, we might be able to generate an alert and say, hey, we're starting to see this anomalous behavior. We can say it's not a critical issue, there's no customers impacted yet, but we're seeing this behavior that could be an indication of a broader problem. And maybe it's tied back to that initial change that we made, that something is holding on to database connections. So that's the real thing that we're looking for when trying to look at and detecting operational anomalies within our workload. So very different than looking at trying to cross certain thresholds or metrics. We're really looking for those trends and patterns where we're starting to go outside of what we would normally see for a given period of time. And I'll show a couple of examples of what that looks like as we start to go through the presentation. So in looking at a high-level architecture of how all of these pieces come together, everything that we're doing is fed by our zCommon data provider. So it is the data source to drive all of the operational data that we need to do both metric and message-based or log-based machine learning. So for metric-based machine learning, it runs on z/OS. It's built on the Watson for Machine Learning for z/OS platform. So we will send data that we have, all of our SMF data that we use for metrics will be used by that and collected and streamed from common data provider. For log-based machine learning, today it runs on Linux on Z. It's delivered as a set of Docker containers. In the near future, we're going to support x86, and we'll also look to, as we start to see additional adoption, support ZCX in the future. So this is our log-based machine learning. It's an easily Docker containerized solution, so it's very portable in terms of how we can go and deploy it. It has a lot of flexibility there. It's taking all of the log data that it's coming and using from Z Common Data Provider. So once it goes through and does all of the training and scoring, all of the visualizations are done through our Problem Insight server, which can run on z/OS, on USS. It can run on Linux on Z, or x86 Linux. So again, multiple ways that we can go and deploy the solution. So let's start to take a look at a little bit more detail, some of what we have for metric-based machine learning. So today we have detailed KPI models for DB2, for KICS, and MQ, with additional subsystems to come. So if you're familiar with the solution and maybe have been involved with some of our user groups, our team of data scientists have worked very closely with the IBM Z subsystem teams to determine what set of KPIs are most useful for each individual subsystem. So once we have that, we go out and do some work to determine how we can derive those KPIs from operational data. Then we'll reach out to all of those different subsystems user groups and go through and do some validation on collection times and validating that these are the right sets of things to look at with broader user communities. So if you've been involved with those, I want to thank you for that. It's been extremely valuable to us. It's still an ongoing process for us as we're doing that. I know we're working through IMS today is the next big one that we're working through. But it takes an awful lot of time and effort to fully understand an IBM Z subsystem. So I know several years ago, IBM had a television commercial here, at least in the US, where in a 30-second ad, it's kind of oversimplifies how much time and effort goes into machine learning. And in that commercial, they had a Watson screen inside of an elevator so that he was going to go and kind of automate the operational function of that elevator. And the next scene in the big high-rise, two technicians come in and ask, hey, the new guy gave us a call. We're here to fix the elevator. And what they kind of gloss over is all of the information that has to happen to go from that point A to that last point, from understanding the operations of that elevator to having the technicians come in. You have to understand the usage patterns of that elevator, how often it's being run, the makeup of the parts, their failure rates, their wear rates, those kind of things, to be able to call and have some of that preventative maintenance kind of work done proactively. So there's a lot of data science that had to go into, fully understanding the operation of that elevator, and IBM Z is no different. And Stephen, I see your question. I'll come back to that in just a moment. It's a very good question that I'll come back to in just 1 second here. So my whole point to that story is, we take a lot of time with our data scientists to make sure that we fully understand and have the right set of information for each of those individual subsystems. So we use Watson Machine Learning for z/OS to build a model of normal behavior from historical operational data. Today we're using SMF data to drive a lot of this. And the question that I got from Stephen is, are we planning to take feeds from tools such as OmegaMon, RMF, and et cetera? And that is an excellent question, and the answer to that is absolutely. So today, The solution we can run in any one of the IBM Z environments because we rely on SNF data, something that is available across the stack, whether you're running IBM monitoring tools or not. So one of the key things that the Omega Mons are working on is being able to use data streaming, to be able to stream some of those KPI values out to various analytics targets, whether it be Elastic or Splunk. One of the things that we are looking at doing is taking that same data and using that to train and run anomaly detection against, and integrating that into our Z Anomaly analytics solution, so that while we can run in any environment, we'll have some additional capability or ways to look at data when our clients have the Omega Mons or monitoring suites as well. So that's definitely something that we're looking at incorporating in, both for training and scoring of real-time data. So today we look at, once we have the models, we'll go and look at real-time scoring of KPIs against the model, and we'll get kind of an anomaly score, and I'll show what those look like here in just a few minutes to really understand how we've deviated away from normal. And Stephen, I hope I answered your question as I was kind of going through there. And then once we find an anomaly, we'll generate an event to alert operations of anomalous behavior. So let's take a quick look at the data flow for metric-based anomaly detection. And again, we're kind of going to go through the two phases here. The first phase is going through the data collection, where we can take SMF in batch and load it into our machine learning database, which happens to be DB2. From there, we'll run a set of CLIs that will let Watson Machine Learning for ZOS go and train on that data. And the output of that is we want to have a model that's representative of each individual environment that we're running against. So think of IBM as providing the data science and the set of KPIs and how we derive those KPIs from operational data, and then we take each individual client's operational data and generate a model that's specific to their environment. So once we have that model, we still use our Z Common Data Provider to stream real-time data into our machine learning database, where we can take those real-time live metrics and compare those against what the model looks like. And from that, we get an anomaly score, and we visualize that through our anomaly scorecards. So this is the kind of high-level data flow that we have coming from training both into scoring. So let's take a look at kind of what this looks like at a high level, and I'll point out a few things as we're going through and kind of refer back to some of the points I've made as we were kind of talking through this. So the first thing is we've done this by each individual IBM Z subsystem. So in this case, we're looking at a scorecard for DB2. I have an example of a KICS scorecard here in just a little bit. So for each one of the subsystems, we've taken a set of KPIs and or each one of those subsystems and broken them down into a set of KPIs. For DB2, there's roughly 80 or 90. For KICS and MQ, there's roughly 60 to 70 KPIs. And for all of those KPIs, we've built out different groups of KPIs. So we've broken them down into logical groupings. So what we can see here on the screen is our storage and DDF KPI groups. There's some for CPU and locks and latches and a number of other things that are specific to DB2. So we've expanded out the DDF, and we're actually looking at our active DBATS KPI. So I'll point out a few things as we're kind of talking through this. So the black line that we can see on the bottom here is what our real-time data looks like. So this is the KPI value that we've seen for the active DBATS KPI over this period of time. You'll notice on this active DBATS graph here that's on the bottom, we have a few different bands of blue. So the lightest blue is what is normal for this environment. So this is essentially visualizing normal behavior for this environment. So We can see that during most of the day, the number of active DBATs is pretty low. We start to see a little bit of variance here around 6 or 7 in the morning, and then we have a big flurry of activity that happens around 9 a.m. But based on what the model looks like, this is expected, and this is what we would see on a typical day. So nothing to worry about as we start to see these kind of wild fluctuations and high points that happen during this period of time. And then we can see as we get closer to noon, we start to go down towards a zero level, and we get back down to a very low number through the rest of the day. So the model indicates that everything that we've seen here is relatively normal for this environment. So we had no high anomaly scores or high watermarks here, as reflected by all the zeros in the anomaly scorecard. The other thing to note is we have the middle band of blue. This is what we would consider low anomalies. This is where we're just starting to deviate outside of normal. And then the darkest blue that we have out here is anything that we would consider highly anomalous. At any time, you can hover over one of the data points, and you'll get presented with this kind of detailed view. So this shows the anomaly scores over the last 10 intervals. And the reason this is important is we're looking for trends and patterns of anomalous behavior again. We're not looking for a single data outlier. So in a lot of cases, we found that IBM Z data can be very spiky. We don't want to look for just a single outlier. We want to start to really look for those trends and patterns. So we can see what the actual KPI value is at this point in time. We can see what's in the normal range and what would be considered a low or high anomaly. If we are experiencing an issue, we can always go down and filter to show just the most relevant information. So we can say, just show me the high or low anomalies. In this case, we're not looking at anything that would be considered high anomalies, so it would just take away all of the data that we have on the screen if we unchecked that normal one. In this case, we're looking at a 24-hour time range. We can always go in and zoom in and get a more fine-grained look as to what's going on. This is especially useful if we're looking at periods where we do have anomalous behavior. We do have the ability to kind of go back and fast forward or rewind. We can go forward or backwards a day. In this case, since we're looking at a 24-hour period, to see what the previous day looked like. We can go backward 7 days. What did this look like last week? Same thing if we're looking at historical data. We can say, okay, let's go forward. What did this look like tomorrow or next week? We can kind of advance through the different time periods and see exactly what was going on within the environment. The other thing that's on the scorecard here is this second kind of graph that's on the top that has, in this case, no real data because we don't have any anomalous behavior. And this is really what's showing what those high-level anomaly scores are. So again, we're looking at those kind of trends and patterns. So this is really what we're looking at for metric anomalies. So a lot of information presented here from just a single graph and the ability to easily drill into additional data and find additional details. So not only can we visualize the model, but we can also see what the real-time data looks like. So let's take a step forward and look at one of our KICS graphs where we're actually experiencing some anomalous behavior. So don't get too alarmed. This isn't something that we had taken from one of our clients to show them what their environment looks like. We had a specific workload that we trained against and then kind of intentionally ramped up some of the KICS transactions to really kind of show what some of the spikes and patterns were. So again, this is looking at KICS data, so a different KPI model than we had seen for DB2, where we have there's storage. We're looking down at the tasks, and in this case, we're looking at the specific transaction count KPI. So as I mentioned, we started to ramp up the workload to go way outside of normal and just kind of gradually increase this. So a couple of things that we can point out. We can start seeing on the scorecard view some of the different high-level anomaly scores. We've also drilled into a 12-hour period, so not looking at 24 hours, and have also filtered out all of the normal data. So we're just looking at the KPIs that are showing low or high anomalies. So very similar to DB2, we can see the real-time data line going through, and I want to point out that as we're going through and kind of going through the low anomaly phase, we're not really hitting those high anomaly scores just yet. So once we start getting a few of those data points that are going anomalous, we can see that start to impact what our reported anomaly score is. So again, this is how we're showing and looking for those different trends and patterns of data, not just a single outlier. So we don't want to flood our systems with events and alerts, so we're trying to be a little judicious on and using some of the industry standard machine learning rules on how we look for and detect anomalous behavior. So just something else to point out as we're going through the metric-based side of anomaly detection. So let me jump into the message side of things. So messages are a little bit different than metrics. We're looking for very different sets of things, and a lot of what we're doing today is keyed off of the message ID found in message logs. This is a great way to understand and see what's going on within those log files in an unattended way. So we still use historical data to build a normal baseline of your message data, but we're looking at different things than KPI or numerical values. We're looking for message frequencies and clustering of messages. And what I mean by clustering is, are we looking for specific sequences? So where we would normally see message A, then message B, then message C occur, those would be considered a cluster of messages. So things that we would normally see in a grouping kind of pattern. So for messages, anomalies are identified in a little bit of a different way. We're looking for things that have never before been seen. So these are messages that are new to the system, that were never part of our training data, that we might want to generate an anomaly event on because this is something that is new and different. We're looking for atypical frequency of messages. So are we starting to see a spike in a number of messages that we hadn't seen before? Or are we starting to see things start to occur out of sequence? And just like the metric-based machine learning, anytime we would see an anomaly, we would generate an event for those. And those events can be integrated into your event management system. I know almost every single one of the ITSM or ticketing solutions will generate incident tickets out of events, so it's a great way to say provide some level of auditability. If we found an anomaly, we can go and say, hey, someone looked at this ticket, they closed it, they said this is not a problem, or if we actually did find this is a problem, it's already integrated into your ticketing system. Much like metric-based machine learning, this is going to follow almost an identical pattern of what the data flow looks like. So Z-Common data will provide a batch load of historical data, again, looking at normalized data. The key differences is where we load that data to. It's not going into DB2. We have internal Kafka, which has Elasticsearch and an internal database to store our messages and models for our message-based machine learning. But just like we see from the metric side, we'll generate a model of what's normal for the environment. And we can then turn on real-time data to compare the live messages with what we would normally see for the model. And the scorecard that we have here is very similar, but it's also slightly different in what we would see for message-based anomalies. So let's take a look at kind of drilling down into what this looks like in a little more detail. So we can see that we have the time scale for looking at message-based anomalies. Messages that or periods that have highly anomalous are shown in this orange color. So we can see that around 11 o'clock we had some message anomalies in this sysplex and system. So with messages, there's an awful lot of details that can be found that contribute to these anomaly scores. So let's take a look at kind of drilling down into this anomalous time period just a little bit. So over this period of time, we have a specific time window where the highly anomalous period occurs. So we have our overall anomaly score that was shown here. The interval contribution score shows how much did this specific message contribute to the overall anomaly score. We have our clustering status. Is this message part of a message cluster or sequence? In this case, the top two were not clustered messages. The next two were actually new messages that had never before been seen. We can see the count of these messages over the time period. And then based on our rules engine, how important are these messages to the system during this period of time? So we have a number of messages that were also viewed as anomalies during this time period that were viewed as not interesting. So, another couple pages of events that were here. But we do have 4 events that were considered important, that were high contributors to these anomaly scores. We can see over this 10-minute interval, every single time that those messages occurred through this little time band. So probably within a couple of minutes into the 10-minute time window, we had the new messages that occurred. We can also see we had a small cluster of the other messages occur. So something must have been going on in the system at that point in time. And we can see that there's different messages for message rates and thresholds that happened for specific jobs in that time period. So something must have been going on within that job during this time that caused those message anomalies. So something that we can easily detect and visualize, again, by looking at these logs in an unattended fashion. So if we want to drill down into the specific history of a message, we can always do that and go and take a look at what that message history was. Taking a look at this, we can see that we have a new message that happened here. This was the first time that we had seen this Q status command. We saw it a couple of times after that a few hours later. So we can always go back and kind of see the history of that message. So that's the quick overview of both metric and log anomalies. I did want to take a few minutes and talk about some of the eventing that we have and how that integrates into Cloud Pack for Watson IOPS. So Cloud Pack for Watson IOPS is an IBM solution that is looking at the entire hybrid cloud stack, from anything that's distributed, that's running on public or private cloud, all the way down to IBM Z. It's taking in events and alerts, metrics, topologies. It integrates with ticketing systems like ServiceNow to bring in ticket information. It can bring in other unstructured data like logs. It'll bring in events and logs from IBM Z. So both Z Anomaly Analytics with Watson, like I mentioned, will generate events as we find anomalies, as well as Omegamons as they start to find anomalous behavior. Watson IOPS will look at bringing in together all of that structured and unstructured data across your entire enterprise to start to correlate all of that information together to really look at the overall health of your application. And a lot of that is driven through the application topology, so understanding is this mobile device related all the way back down to this DB2 or KICS region. So maybe we see an event that says our banking application is taking a very long time from my mobile handheld device, and we have an event of an anomaly from Z Anomaly Analytics with Watson that shows our KICS response times have really spiked. Through the topology, it'll start to correlate those events together and say these are indicative of the same problem. So once we have all of this information coming together, we can start to correlate that information. We can start to diagnose the problem. And Watson, Cloud Pack for Watson IOPS, as well as You'll likely hear about Z chat ops and how they integrate through the conference over the next couple of weeks. But through the notion of chat ops, we can start to bring all of that information together. So we can see that we have a new incident that's been detected. We have a set of our ticketing service. We can see the blast radius. So what the blast radius is looking at the topology and seeing where we have events come from, and looking at what other parts of our infrastructure might be impacted because of these events. We can see anything that we have from tickets that might have come in. We can see that we have 2 alerts. We have 2 log anomalies that have come in. And if we want to go and take a look at one of the relative events, we can see one of these had come from our Z Anomaly analytics for our max DBAT KPI, and it'll drill us directly into that scorecard view so we can start to drill down and understand what's going on within the system. So it's very good at correlating all of that information across your entire enterprise to really get down to paint the big picture of what's going on within application issues. So Z Anomaly Analytics will certainly show you from the anomaly detection standpoint and alert and show, hey, we're seeing log or metric anomalies. The Cloud Pack for watching IOPS will start to correlate all of those different events and anomalies with other indicators that are going on across the different systems. So that's one of the use cases that we can do other than just the standard alerting or turning those into tickets or events to alert somebody that we need to go and take a look at this anomaly. How those can be consumed by another solution. So that really gets us through the presentation today to talk about how our approach to anomaly detection is used, from that training phase to looking at real-time data across metrics and log data, and how when we detect anomalies we can generate events and integrate those events into broader solutions and systems. So again, this is really a key piece of the puzzle and an evolution and a different way and a different approach to detect operational issues, and really trying to get that down to real time instead of waiting until we hit maybe some of those dynamic thresholds that we had done a long time in the past. So as I mentioned, Z Anomaly Analytics is a new solution that was just announced this past August and made available in September. It is a derivative from Z Operations Analytics, but the links for the announcement are here. You can go and find additional information on the product page. The other thing, if you haven't seen it, there's a great IBM Z community. There's an IOPS part of that community that you can go and see a number of blogs about a lot of the capabilities that we've done and see some of the enhancements that we're doing. If this is of interest to you, I would always ask, you can always reach out and we can go through a rapid POC where we can take your data and show you what it looks like within the solution. So we can go and take historical data and build the models and then show what some of that data looks like being compared against that model. So we've seen some very interesting things as kind of going through that process. So I know Anna will ask me to make sure to remind you to, as part of the solution, to make sure you submit the solution feedback. The link is there. Again, this session was 3AD. And with that, Anna, I don't know if you want to cover being the slide to become a member of GSA UK and all the benefits that are there. And I think we have about 10 minutes here at the end that we can leave for any other questions. I didn't see any other ones come through the chat, but I'm happy to answer questions live here at the end of the presentation. Okay, so everyone is able to unmute yourselves to talk with Daniel. And yes, being a member of the GSE community does give you certain benefits. Some of them are really only valid for when we have the face-to-face conference, which we hope next year will be the case. But as you can see, there are other things, and in fact, for this conference, only members are going to be able to
download the recordings, I believe. So just for that, it's probably worth it. There are individual memberships as well as company memberships. Okay, so if anybody's got any questions, please feel free. And just to remind you that feedback, please, and also the charities. Thank you, Daniel.
You're very welcome.